Hello guys, we're here with another step question and it's going to involve a little bit of graph sketching, a little bit of integration, and then knowing our double angle formulas very well and being able to derive some reduction formulas based off of that, reducing powers. So let's get right into it. This graph that I've drawn here is y equals x cos x. Okay. And it's going to look like this because as x is small, cos x would be large. So like x is 0, so we're going to have 0 here. This is pi over 2 here. And at pi over 2, cos of x is 0. So we're going to be 0 here. And then if we look in the middle, okay, we've got a point where we've got a relatively larger x as well as a relatively large cos x. So this is why it's going to be shaped in this way. Okay. If we look at the graph of y equals sin x, it should look something like this, and as I hope you'd know, it goes like that. Okay. And what we notice here is, so we're looking for sin x minus x cos x. They're not going to intersect, and we can do that by setting them equal. And then we can divide through by cos x, so we can have tan x equals x, which shows that they intersect at 0, and then that they won't pass this point. Okay, so that's helpful. And, well, in this domain that is. So, when we're looking for y equals sin x minus x cos x, it's easy to see when we've got them drawn next to each other. So we've got pi over 2 here. 0, remember that. So we can see it's going to look somewhat like an exponential graph. Not quite, but like it's going to grow a bit. And we're going to make this point that, okay? And then this here, we can see is pi over 2, 1. By looking here, where this is equal to 0 and sin x is equal to 1. Okay, so that's quite standard. We need to show that y is also between 0 and 1, okay? And the reason we know that is because sine of x is always going to be less than 1, okay? And greater than or equal to 0. As well as that, we know that x cos of x, okay, is less than or equal to sine of x, okay? And it's only equal to that when we have x being equal to 0, so that's not taken away. So therefore we know that sin x minus x cos x, okay, is going to live within this range, okay? So that's quite nice, because we're taking away from sin x, it's not going to be greater than 1, because x cos x is positive here. So I'd write that down, but I'm just explaining it to you, because this is a recording. So now I've got some integration using y, which we had earlier. So it's in the same range, which is nice to notice. And this first integral is going to be very, very standard, which is quite nice. Okay. Integral of sin x is going to be minus cos x between pi over 2 and 0. Okay, and then for this x cos x, we're just going to use parts, okay? So, first of all, I'm going to write, this is a new integral. Okay, and then over here, I'm going to set u equal to x, v prime equal to cos x. And then this is very standard from that point, okay? So, let's evaluate this first. Cos of pi over 2 is 0, so that's going to cancel. Cos of 0 is 1, but it's negative cos x, and that's a negative limit of our integral. So it's going to be a double negative, which will mean 1, okay? So we need to take away uv, because we have minus sign here. So x sin x, and that's, again, in between these. Okay, and plus, because there's a double negative, integral between pi over 2 and 0 of sine x dx, which we know is 1. Okay, so we're going to have 2 minus this. Okay, when x equals pi over 2, okay, x turns into pi over 2, sine of x is 1. So this is pi over 2, okay, and then we should notice it turns into 0 when we plug in 0 as x. Okay, so that's correct. Very, very simple integral. Now it's a little bit harder. So we have still between pi over 2 and 0, however it's y squared. So this is sine x minus x cos x squared dx, which we can expand to make sine squared x minus 2x cos x sine x plus x squared cos squared x dx. So this is actually the first part in this question where it's anything really kind of past what you'd do at A level and slightly trivial, other than maybe the graph sketching. So what we need to look at here is our double angle formulas. So you should know that sine of 2x is 2 sine x cos x, and that cos of 2 of x is going to be equal to cos squared x minus sine squared x. Okay, so this one first, we can also see that we've got this very simple. So this is similar. So this is just going to be minus x sine of 2x, okay, by just comparing this. But now we need to reduce these powers because they're difficult to integrate. So for this, we want to use our sine squared plus cos squared x equals 1. So sine squared is 1 minus cos squared x, and vice versa. So to find our reduction for cos squared x, this is going to be, because we have a double negative when we plug in 1 minus cos squared x, we have cos of 2x being equal to 2 cos squared x, take away 1. So this you can simply rearrange and you have cos squared x being equal to cos of 2x plus 1 divided by 2. Okay, similarly, you can see here that cos of 2x is equal to, we have 1 minus sine squared x minus sine squared x, so 1 minus 2 sine squared x. So sine squared x is going to be 1 minus cos of 2x over 2. Okay, so the first thing I'm going to do is take out a half, because we have 2 times with a half. So it makes a lot of sense to simplify integral in this way. Sine squared x is 1 minus cos 2 of x. Okay, very nice. So minus, we've already realised that this is going to be minus 2 sine of 2x. The reason that we have minus 2 here is because, sorry, I think I may have said that this is minus 2x earlier, which it's not yet. But the reason why this is minus 2x is because we took out a half. So it would just be minus x times sine of 2x. However, we took out a half, so it's 2. Okay. And then this is simply plus x squared. And this is 1 plus cos 2x. Okay. And then this whole thing is dx. What I'm going to do now is I'm going to split the integral into things that we can and can't simply integrate. Okay, so 1 we can integrate very easily. minus cos of 2x, we can integrate very easily. And then plus x squared, we can do very easily. Okay, but then we need another integral between pi over 2 and 0 again. Sorry for the dogs. So this is going to be x squared cos 2x. And then that's going to be minus 2x sine 2x. dx. Okay, so here we're going to use integration by parts on the right. However, first let's do the standard stuff. What's important on this question is, while we have a lot of standard processes, this can get slightly complicated algebraically, so we need to organize everything nicely. Okay, so first things first, we're going to take out this half. Okay, 1 integrates to x. Minus cos 2x is minus sine 2x. Okay, and then if you differentiate that, you'll realize that we need a 2 for it to be minus cos 2x. And then the minus stays. And then plus x cubed over 3. And then this is going to be between pi over 2 and 0. Okay, so we have 2 parts here. So I'm going to write our integration by parts over here on the right. So we can make u equal to x squared and v prime equal to cos of 2x. Therefore v is going to be sine 2x over 2. And u prime is going to be equal to 2x. Okay. And then we're going to have minus 2x sine 2x. I'm going to forget about that negative when I do my by parts, just for simplicity. However, I've noticed where I can reuse it, but I'm going to leave that at first for simplicity. So 2x and then v prime equals sine of 2x. Okay, v is going to be equal to cos 2x over 2. And so now, this would be negative. However, we've got negative here. So what I'm going to do is cancel those later on. But I'll leave that left now. U prime equals 2. Very standard. Okay. So here, we've got pi over 2. Okay, sine of pi is 0, and sine of 0 is 0. So this all cancels. And then plus x cubed is going to be pi over 8. Pi cubed over 8. And it's going to be 24 when we multiply the denominator by 3. 0, these two will cancel. Okay, so now let's do this. We have plus x squared sine 2x over 2. Okay, very nice. And then we're also going to add, because of the double negative, x cos 2x over 2. Okay, with pi over 2 and 0. And then this is going to be, we're going to take away the integral of half sine 2x times our x. Okay, and then we're going to take away. So let me just double check. We've got a minus here for our minus cos 2x. Integration by parts gave us this minus here, so I'll leave that. And this minus, so I think it's a positive. Yeah. Positive cos of 2x. Remembering that we multiplied by that 2 from our u prime. Okay, so we've got pi over 4 plus pi cubed over 48. Sine 2x with these limits cancels to 0. You've discovered that. Okay. X cos 2x, so that's going to be pi over 2 times minus 1 over 2. So that's going to be minus pi over 4, and then it'll cancel to 0 when x equals 0. So this is plus a half minus pi over 4 in here. Okay. And then minus this integral. I'm just going to do by parts again. So okay, and then we've got a standard integral as well. So this is minus a half of sine 2x over 2, which we know cancels. Okay. And then we have plus a half of cos 2x over 2. From our integration by parts. And then we're going to have a triple negative, I believe. So it's minus the integral of cos of 2x over 2, which we can recognise now will have a sine 2x, so we can cancel that all out. Okay. So we have pi over 4. Okay. Let me just... pi over 4 plus pi cubed over 8, 48. Minus pi over 8. Okay. And then this is going to be, we looked at this earlier, however it had an x. So this is going to be, okay. This should have an x. Okay. And this was minus pi over 4. So we have pi cubed over 48 minus pi over 8. And that should be what we're looking for. Alright, perfect. So now we need to deduce this. So what's very useful here is, like many step questions, it links back to this first part. So because we're in this domain, or range within this domain, so let me explain that more coherently. When x is in this domain, y will be in this range. When y is in this range, y squared is always less than y. Okay? So due to this, and then we know that it's non-zero. Okay? Due to this, we can know that our pi cubed over 48 minus pi over 8 is going to be less than our 2 minus pi over 2, I believe it was. Okay, that's correct. So from this, it's relatively simple. We have pi cubed over 48 plus 3 pi over 8 is less than 2. Which gives us pi cubed 6 times 3 plus 18 pi is less than 96, and that's what we're looking for. So yeah, I'd say this is one of the easier step 2 questions, but it is easy to go wrong in this area, as you can see from my working. I've tried to be as neat as possible, but it's still, you know, there's a lot of weird algebra and sign errors. what you've got to look for is repeated terms and places you can cancel out, for example, when you have a sine 2x. And using that, I'd say it's not too difficult, and there's minimal problem solving. I'd also say, if you can, try and remember these solutions for the reductions, because it could save you a lot of time in an exam. For example, if you're taking a step paper, this could take you a couple of minutes to do and save a lot of time on a question like this. And yeah, so I hope you learned something, and I hope this helped. Quite a nice solution, and I liked the way that it linked back at the end, so that's also something to follow.